Moving right along. Last time we left off, we were talking about solving certain types of radical equations. Now, radical is not a really lame word from the 80s for cool. In this case, radical means it involves, well, some kind of radical. So let me write a little smaller than that. So let's say we wanted to solve this equation, the fourth root of some expression x minus 18 is equal to 3. Our goal is to solve this equation. Let me draw a better 3 than that. That works. Well, one thing we should discuss, one thing we should bring up, how would I solve that? Well, last time we talked about, we kind of glossed over it, I didn't formally introduce it, something called the power property. The power property, it's not as cool as it sounds. It sounds very cool, like a comic book thing, but it's not. The power property says if, generally speaking, you can raise both sides of an equation to any power you want, kinda. You can kinda do it. What happens is you might accidentally be introducing new possibilities for solutions that actually shouldn't be there. So if you're going to use the power property, raise both sides of an equation to something, you need to check your solutions in the original equation, make sure they make sense. And that's going to be very crucial here. So what we can see is because we're taking a fourth root, you might recall that the fourth root can really be written, it can be said that it's that expression raised to a 1/4 power. So all I've done is rewrite the equation. I haven't done anything closer to solving it. Well, if I want to get rid of a 1/4 power, I need to raise both sides to a number. What number shall that be? Well, the reciprocal of 1/4 rather. I need to raise both sides to the 4th power. Just like we solved an equation last time where there was a square root radical involved, and a square root is really a 1/2 power. So I had to raise both sides to the 2nd power. I had to square both sides. Now I'm raising both sides to the 4th power. And what that's going to do is that's going to have this wonderful little effect here. Those are basically going to cancel each other out. Because really what I'm doing is multiplying those powers. And 4 times a 4th is just 1, which is the whole kit and caboodle behind this. And so what I'm going to be left with is just x minus 18. Hey, that's not bad on the left-hand side, x minus 18. And then what is 3 to the 4th power? Well, 3 to the 4th, that means we are taking 3, multiplying it to itself, so basically 4 total times. So let's think, 3 times 3 is 9, so we've done it twice. Let's see, then we have, let's see if someone revealed it, 81, Raina, that is correct, very good. And now, do you guys see any weird radicals or any funky, fancy business going on here with this one? I don't. I don't see that issue going on. So what would I do here to solve this one? Add 18 is exactly correct. Add 18 plus 18. And now I'm going to leave me with just x by itself equal to 99. Always a fun one. So x is equal to 99. Now, am I happy to just sit on that and not do anything with it and say, that is for sure the answer? No, I'm not. Remember, if I raise both sides to a power, we need to check. We need to make sure it's going to work. So we're going to check it. That's a check mark, not the Nike logo. I'd get sued. Check it. I'm going to take this 99. I'm going to, looks like John Madden over here. I'm going to plug that 99 in for X in the original equation and just make sure I've dotted my I's, crossed my T's. So we're going to plug 99 into the original equation. Fourth root of 99 minus 18. And what we're really asking is, hey, does that come out properly? Does that equal 3? But it turns out it's going to work. You're going to end up with the fourth root of 81. You're asking, does that equal 3? Well, let's see, what's a number that multiplies to itself 4 times to give you 81? We kind of already argued that. Yeah, it's just got to be 3. It's the only thing that's going to work. That's how you take a fourth root. So 3 does indeed equal 3. Check. So x equals 99 is the solution. And not 9, not just 9. There we go. Everyone say yay. I heard some yays. That's good. The yays have it. So let's do a couple more. Let's do a few more of those, these kind of equations, especially because we've got a little extra time given back to us today. So we're going to use that power property. I can raise both sides to any power I want, but pick a smart power. In this case, we picked a fourth power because we were originally had a 1/4 exponent going on. So the fourth power did away with that. So let's try out a couple more. Solve. Let's see. How about in parentheses, x squared plus 24x. And that's going to be raised also to a 1/4 power. But what we're going to see is this is going to come out a little bit more complicated to find the solution, to find the appropriate solution. All right, guys, this is actually deceptively, or almost, it's not really deceptively, it's very similar to the last one we just worked. What are we going to do? How are we going to get rid of this 1/4 power? Well, we need to raise both sides to the fourth power, to the reciprocal of that. Just like the last one, so it's actually going to play out very similarly. On the left-hand side, those go away. That was the whole point. We're going to be left with x squared plus 24x equals, we already argued, 3 to the 4th is 81. Let's make that look better. So x squared plus 24x equals 81. Now what we need to do, there's a couple things we can do. We can complete the square. That's perfectly valid here. We could use quadratic formula. I'm thinking we can avoid quadratic formula here. We can also try factoring it. So between completing the square or factoring it, someone tell me what we should do here. Someone text me in the text box. What do you guys want to see here? Factor. All right, I'm down for that. So to factor it, we need everything on the same side of the equation. So we need to move that 81 over by subtracting it over. Okay, so we have the very fortunate situation where we have our x squared term secretly has an implied 1 in front of it. And that generally makes our factoring life a lot happier. So what we do now is we go look at this negative 81. There we go. Negative 81, and we need two numbers that multiply to negative 81, but if I add those numbers, I get positive 24. Can anyone think of two such numbers that are going to do that for us? Let's see. Well, 81's, not a fun thing to deal with. What do we got? 27 and 3, very good. But with a caveat, you're right. That's going to essentially be it. One of them's got to be positive, one of them's got to be negative, so that they multiply to negative 81. So which one should be positive? Well, it looks like the 27 should be positive, and then the 3 should be negative. So positive 27, but negative 3. Multiply them together, you'll get negative 81 as required. But if you add them, you're going to get 24. Well, that's cool because that means the factoring is going to be pretty gosh darn easy. Now, don't tell anyone I said gosh darn in the classroom or, oh, I'm in a heap of trouble. It's not true, but hopefully you guys like my humor. But if I'm being realistic, no, nobody likes my humor, and I need to just give it up. I need to quit thinking I'm a comedian. Get serious. Anyways, the inner monologues of me. Okay, so we can factor it like this. X squared minus 3x plus 27x. Those would combine into just positive 24x. Then 27 times negative 3 gives me the negative 81. So that does indeed factor pretty cleanly. Now what that's going to do is that's going to give me two possible solutions of negative 27 and positive 3. Negative 27 from this, remember you set each factor equal to 0 and solve it. That would move the 27 over, move the 3 over, and flip their signs basically. So these are proposed solutions, but my intrepid friends, those are potential solutions. Should we check our solutions with these types of equations? And you all say yes, you are correct. You could probably tell from the tone of my voice that, yeah, you're supposed to check it. I need to start trying to trick you guys with the tone of my voice and say, make it sound like you should, and then it turns out you shouldn't. Something like that. I need to figure that out. Maybe for another time. Yeah, we need to check these potential solutions here in the original equation of x squared plus 24x to the 1/4 power equals 3. Well, I'll just tell you right now, the 3 will work. Let's try the 3 real quick. So we're going to have 3 squared plus 24 times 3 raised to the 1/4 power. We're asking, does that equal 3? And it turns out it will. That's a closed parentheses right here. Let me make that a little bit better. You're going to get 9 plus 24 times 3. You can do the quick side calculation. It'll be 72. You can get 81 to the 1/4 power. You're asking, does that equal 3? Well, remember the 1/4 power is the same as just taking the 4th root. And we already argued earlier that the 4th root of 81 is indeed 3. So this one gets a nice big check mark, the 3. Yay, I can use a stamp. The 3 works, however, and this isn't always true, you don't always just automatically throw out the negative possibility. Sometimes it is the right answer. when you try negative 27, basically the problem that's going to happen is that it's going to be awfully hard to make this positive inside here. So the negative 27 is going to just kind of create problems for us. Let me double check that. Let's see, 27. Well, actually, it's going to create really large values, and so we can certainly try it. Actually, I think it's going to work. I'm going to eat my hat here if it does. Let's see. Negative 27 squared plus 24 times negative 27. And that is all to the 1/4 power. We're still asking, does that equal 3? Well, negative 27 squared. We know if it's a negative number being squared, it's going to become positive. And then it looks like we just need to do a little bit of side multiplication over here. So 27 squared is just 27 times itself. Do a little side calculation. 14,540. And so just so you kind of see how these things go, you're going to get 729 positive. That's key. Over here, you're going to get 24 times negative 27. So even though I'm adding it, these two are multiplied to a negative number. So it essentially becomes subtraction there on the inside, raising it to the 1/4 power. And so now we need to do 24 times negative 27. So, or just in this case, 24 times 27. I'll make it a little smaller here. And what you'll see, and I want to show you the old school multiplication to show you you do not need the calculator. 7 times 4 is 28. Two times 4 is 8. 2 times 2 is 4.
Uh, 27 times 4 plus 27 times 20.
And so you actually do get 81 to the 1/4 power here. And so we know that works. We know 81 to the 1/4 power works. And so this one also gets checked. So pardon my French, not French, pardon my mistake. Yeah, actually both of these are going to work here. Both of these will create solutions. So we did the math, then checking the solutions. Well, that requires some extra heavy lifting we have to do, but it's because of that power property. We raised both sides to a power. We raised both sides to the 4th power. To solve it, we had to make sure that the solutions we got worked. Does that make sense? Is that cool? Awesome. So the next thing we're going to cover, the last topic really of this section, we're going to talk about equations that are in what is called a quadratic form. A quadratic form. And what this means, we're going to look at equations that don't look like they're quadratic equations, that they're just x squared type equations. But with a little substitution, these are equations that can be turned into a quadratic equation. A little quick substitution, and you'll see that you can turn them into quadratic equations almost overnight. It's like a miracle drug. So kind of the best way to do this one is to just lead by example. How about we try out 6x to the fourth, so fourth power, minus 19x squared plus 15 equals 0. Now here's the rub. This is a fourth degree, what we call polynomial, fourth degree expression that we now have to solve. And it's not very easy, it's not very pretty to work with normally, but notice you're missing a third degree term. There's no third degree term. There's also no regular x term, x to the first power term. Those have been completely glossed over. You just have a fourth power, a second power, and then the constant. That actually means that this is in a quadratic form, because what we could do, if you were, say, bored, you could make this substitution. And you will believe me, substitution. Check this out. What we're going to say is some other variable, y. We're going to say let y be equal to x squared. Why should we do that, Josh? Well, because then when we come back over here, what we're going to see is that this can be rewritten in terms of y, and then when you do that, it's going to look like a quadratic equation. Because if you think about it, before we rewrite it in terms of y, you could say that 6x to the fourth was just 6x squared. Because if you take x squared and then you square it, you would really just multiply these two powers and end up getting back to the 6x to the fourth you had up here. So that's actually going to be the understanding we have. The 19x squared doesn't need to be touched. We can leave that alone. And now I'm going to apply my substitution. Anywhere I see an x squared in the problem, I'm going to substitute it with the variable y, because y and x squared are equivalent. You're going to use substitutions all the time in mathematics. If you're going on to calculus, if you ever plan on taking a calculus course, you're going to use integration methods called U substitution, trigonometric substitution. There's all kinds of places where you are going to be wanting to use a substitution method, where you want to put one variable in for the other. And look what happens when we do that. We're going to end up with 6y, and now the y takes care of the x squared inside the parentheses here. But there's still a squared even outside of that. So you're going to end up with 6y squared minus 19. Well, x squared we're calling that y, plus 15 equals 0. So suddenly we started with something that didn't look quadratic. It was fourth degree, all the way at the top. But with a little substituting, we were able to get a quadratic out of it. And that is just really cool. But here's the catch. The substitution we did isn't just going to disappear. It doesn't just magically go away and we can, frolic in the fields and laugh and sing. No, we're going to have to revisit the substitution we made whenever we are ready. You'll see in a moment, it's just going to make sense. We're going to revisit that substitution because remember, our original variable is x. And we can't forget that. We're trying to solve for x. We're only using y as like a tool to help us really get down to x. You could have called this second variable anything you wanted. You could call it z, you can call it w, you can use Greek letters, you can make up your own symbol. It doesn't matter. I didn't use it as like x and y when you graph them. I just used it as an arbitrary variable meant to represent x squared. Okay, so now we must endeavor to solve this quadratic equation. I think this is a good opportunity for us to review quadratics, solving quadratics, because as you've probably figured out by now, that's going to be a very key part of your first exam here, is just being able to solve quadratics, figure out if the solutions make sense, all that business. So maybe we'll take this opportunity to solve this quadratic. So we've got 6y squared minus 19y plus 15. The normal procedure, if you want to factor, well, the problem with factoring is it's not always guaranteed to work. It's not always going to happen. What we've been doing is we have been using quadratic formula. If you remember that, negative b plus or minus the square root of b squared minus 4ac all over 2a. We've been using quadratic formula. We've been using completing the square, but I say we do attempt to factor this one. I say we make a good old college try, and it may not work, but we always give it a shot. So let me show you the factoring technique I was kind of brought up under myself. The first thing we're going to do is we're going to take the term in front of this, the coefficient of the squared term, the 6, and multiply it to the constant term. We were kind of glossing over that because earlier we had a 1 in front of the squared term. So we didn't actually have to do the multiplication. But here we do, because it's not a 1. So you do 6 times 15. Maybe you can figure out that that's going to give you 90. Certainly, you are free to do, well, I guess is kind of the term, old school multiplication. Do 15 times 6 down here. You would realize that you're going to get to 90. Now what you're going to do is now, just like earlier, we need to find two numbers that multiply together to give you positive 90, but when I add the numbers, I get the negative 19, the number in front of the single y term here. Can you think of two such numbers that's going to do it? Let's see, two numbers. Well, if they have to multiply to a positive number, but add to a negative number, then the two numbers that are going to work are going to be negative 10, or excuse me, they've got to both be negative. I almost just spilled the beans there. I basically did. Yes, thank you, Anna. You are correct. Negative 10 and negative 9. They both have to be negative. Negative 10 and negative 9. Yeah, multiply them, you get positive 90. Add them, you get negative 19. But there's one little catch here. I can't just write it as y minus 10 times y minus 9. That would be great, but that little trick is only a shortcut when there's a 1 in front of the y squared term. If you don't have that, which we don't have that here, you're going to have to use an alternate method. Not horribly different, but a little bit. We argued before, we've mentioned before, how technically coming into this course, it's assumed you know how to factor. But I think whether you do or don't, I think it's good to maybe learn this little slightly new method called factoring by grouping. It was all the rage fairly recently. Here's what we're going to do. We're going to split off this middle value, this negative 19y, into two different terms based on these two numbers, negative 10 and negative 9, that we found. I'm going to split that off into minus 10y minus 9y. If we were to recombine these as like terms, and we're just going to rewrite the 6y squared over here, and the plus 15, that doesn't go away. You'll notice, well, why would you do that, Josh? Because I would just combine these two things as like terms and get back to negative 19y. Why are you, splitting it back off instead of combining them? Because once I do that, and this only works because I found these two numbers that have this wonderful property over here, I'm going to split these into group 1, call that group 1. I'm going to call this group 2. And what I'm going to do is I'm going to look at just group 1, and I'm going to take out the greatest common factor. So I'm going to take out the GCF of each group. So I'm going to look at 6y squared minus 10y. First, I look at the numbers 6 and 10. What's the greatest common factor between 6 and 10? I'm thinking it's going to have to be 2. The largest number that divides cleanly into both of them, the greatest common factor, or the greatest common divisor, it's sometimes called. But then I also have to include the variable. We have y squared, which is essentially like y times y, and a single y. So the greatest common factor is going to end up being 2 times y. And when I take it out of the first group, that's going to leave me with, well, now we need to divide it out of this. 6 divided by 2 is 3. Y squared divided by y is just a single y. Another way to think about it is, if these two were to multiply together, do I get back to the 6y squared? And the answer is a yes. I definitely get back to the 6y squared. Now we need to divide 10y by the 2y. We're just taking out the greatest common factor. And I'm going to say that 5 will do it. 5 will get that done. If you don't believe me, try redistributing this 2y back out. You will get 6y squared minus 10y. So we take the GCF out of group 1. Out of group 2, we're also going to take the GCF out. But here's a hint. We don't want to lead with a negative number. So I'm actually going to take out, we see that the GCF would be 3. Because 3 is the largest number that divides into both 9 and 15. And I don't have to worry about a y because this thing doesn't have the y with it. So the GCF can't involve the variable here. But sneakily, I'm going to take out a negative 3. And so what that's going to do is flip the signs. By taking out a negative 3, this becomes positive. The leftovers are 3y. If I take a negative 3 out of positive 15, that's just going to flip the sign. Now, between this thing here and this thing here, notice that they both share the 3y minus 5 business. The 3y minus 5. Now what we're going to do is we're going to take the greatest common factor out of this whole expression. And the greatest common factor doesn't have to be just a single expression by itself. It can be an entire term like this, an entire binomial. So what we're going to do now is we're going to take 3y minus 5 out. And it's going to end up looking like this. (3y minus 5). And what's left is 2y minus 3. Ooh, that's really cool. Cool is a relative term here. That's really cool here because what you're going to have then is the factored form. We've taken 6y squared minus 19y plus 15 and we've factored it. And if you don't believe me, try foiling it back out. You'd get 6y squared minus 9y minus 10y, and those combine to minus 19y, plus 15. That's really slick. Now, if you have your own way of factoring things that don't have a 1 in front of the squared term, sometimes there's a guess and check method, the FOIL method it's sometimes called. If you got that, let's not fix what ain't broke. If you were comfortable with that, if you could have factored it down to this on your own, then I'm totally fine with that. Oops. Okay, so now we've got a little bit more work to do. We're not quite done, but we've gotten almost all the way done. Let's clear some of the whiteboard here. And so now I'll leave the original equation and then I'll bring this part up here. Now we just have to solve each one, set each equation to 0, or rather set each factor to 0. And hopefully you can see this, add 5, divide by 3. Over here, add 3, divide by 2. And so we've got these two values for y. We've got these two values for y. But wait a minute, pump the brakes. Was our original variable in the equation, was it a y variable? What do you guys think, yes or no? No, our original equation was not in terms of y, it was in terms of x. Shouldn't it be 3 over 2? You are correct. Hopefully that will clear up your confusion. Yes, very good. 3 over 2. See, even I make mistakes. But whenever I make a mistake, it wasn't really a mistake. I was seeing if you were paying attention. And you know, that's the classic line that you use to cover yourself. Yes, very good. Thank you for pointing that out. Yes, it's 3 over 2. Add 3, divide by 2. But our original variable was not y, it was x. So now what we can finally do is we can undo the substitution. Oh boy. Substitution's an unfair word to spell sometimes. We can undo the substitution. And what I mean by that is we need to get back in terms of x. Since y is equal to x squared, I'm going to reapply x squared. And now x squared is equal to 5/3. And on this one, x squared is equal to 3 over 2. And now the beauty is ready to unveil itself, is ready to reveal itself. Now I just need to solve each of these equations for x. I need to solve these equations each for x by using the square root property. So use square root prop. That means I would take the square root of both sides, yes, but remember that creates that plus or minus situation. So wait a minute, Josh. That means there's actually 4 possible solutions. Positive, square root of 5/3. Negative, square root of 5/3. Positive, square root of 3/2. Negative, square root of 3/2. Yeah, there's 4 solutions here. 4 different solutions. They're not going to be pretty numbers, but that's what it is. There's 4 different solutions here. And if you know a thing or two about algebra, we're going to talk about something called the fundamental theory of algebra a little later on in the semester. You'll see that if you have a true polynomial, which we do here, we'll also define a polynomial formally, then the highest power, which in this case is 4, the highest power dictates the maximum number of solutions possible. So it doesn't guarantee you'll have 4 solutions, but in this case, it does mean we can have up to 4. And since we do have 4 here, we can comfortably say we found all the solutions. So these are the 4 solutions. You'd literally write square root of 5/3, negative square root of 5/3, square root of 3/2, and negative square root of 3/2. And you don't have to involve I because there's no negatives on the inside with the square root. The negatives are on the outside. So they're all real numbers. All 4 values are real numbers that do not involve I. Let's look at one more of these quadratic form type things. You're going to have to use a substitution. Let's look at one more possibility. And because we are not content to just make things as straightforward as possible, we're also going to bring negative exponents into this. Negative exponents. So let's look at the equation. X to the negative 2/3 power plus x to the negative 1/3 power minus 2 equals 0. Let's draw a better 0. Ode to joy, I say. We have negative exponents and we have fractional exponents going on. How can we handle those? Well, here's what we're going to do. The first thing we're going to do is make our substitution. And once we make our substitution, we're going to be able to solve just a simple quadratic here. So it can be hard to see this, but the substitution we're going to want to make, and we'll ask for permission instead of forgiveness in this one, we're going to let y be x to the negative 1/3 power. X to the negative 1/3 power. And let's see why that makes sense. Let's rewrite our original equation in a friendly manner. X to the negative 2/3 could, if we wanted to, be rewritten as x to the negative 1/3 squared. X to the negative 1/3 squared, because I would just be multiplying these two powers and it would get me back to the negative 2/3 power. So I'm rewriting it like this because it makes making our substitution a lot more straightforward. The rest of it, we're just going to reproduce. Now we can make our substitution. Anywhere we see x to the negative 1/3 power, we can just write y. So that's going to end up just being y squared plus y minus 2 equals 0. And now we just have to solve this equation, but because our original variable was x, we're going to have to deal with it as we see it. So let's see. Y squared plus y minus 2. This one can be factored. This one's going to be pretty straightforward. We have a 1 in front of the y squared, so that makes our lives even easier. So we need two numbers that multiply to negative 2, but if I add those two numbers, I get positive 1, which is the coefficient of the middle term here. Can y'all think of two such numbers that do that? Let's see what we got in the chat box. Positive 2, negative 1 is correct. So we're going to end up with y plus 2 times y minus 1. Boom. Don't believe me? Try foiling it back out. After you do so and you combine like terms, you will get this exactly. Very good. And so that then produces these solutions. y equals -2, y equals +1. Very good. Now, here's what we can do now. These are not the final answer. We'd love them to be. It would be wonderful if they were. These are our proposed solutions. These are what we hope are going to end up helping us. But remember, our original equation was in terms of x. Our original equation was in terms of x. So what we're going to do now, we're going to undo our substitutions. And we're going to rewrite x to the -1/3 power in for y. Now, here's what we have to do. We need to solve these for x. There's a couple things we can do. The first possibility, we need to deal with the negative power. We can actually raise both sides to whatever power we need in order to get x. So we need to, well, let's think. I need to raise both sides by some power that's basically going to make this exponent here a +1. Now I'm thinking I need to raise both sides to the 3rd power, kind of like we were doing earlier, because that would get rid of the 1/3. And you're almost there, but it's a -1/3 power. I need those negatives to cancel out, so it actually has to be I raise both sides to the -3rd power. Basically, we take whatever the reciprocal is of this, and we raise both sides to it. -1/3 has a reciprocal of -3. The reason that works is because that's going to give me just x to the 1st power when I do that. -1/3 times -3, the negatives multiply and give you a positive. The 1/3 and the 3 multiply and give you just 1. And that's what I want, because I just want x, which is secretly x to the 1st power. I just want x. So we're going to get just x by itself. Now, how in the heck do I raise something to the -3rd power? How do I deal with negative powers? Well, don't be fooled. This -2 up here and this negative in the -3 don't do anything with each other. They don't multiply and become positive. Because I'm taking an exponent, I'm not multiplying -2 times -3. I'm taking -2 and raising it to the -3rd power, to this exponent here. So here's what exponents do. Here's what negative exponents do. Negative exponents are secretly division of some kind, or they secretly become reciprocals. Here's what's going to happen. When I have a negative power, okay, I get rid of it by realizing that I'm now going to put it on the bottom of a fraction. And now I can deal with +3rd power down here. Let that sink in for a moment. We're going to be using that property a lot. If you take a number, say 4, and you raise it to the negative power, it reciprocates it. It makes it like 1/4, and then that 5th power doesn't go away. It just shoots it into the denominator, but now I can at least have a positive power down there in the denominator. Negative exponents secretly cause me to reciprocate things. And there's a good reason they do. But for now, that's something we're going to take a little bit on faith. We're going to say, okay, negative exponents cause reciprocation. It gets rid of my negative power and makes it positive, but we got to put it on bottom. And so now what it becomes is 1/. Now we got to think about what -2 to the third power is. You do -2 times -2, that gives you +4, but you got to do it one more time, and that gives you -8. And so ultimately that becomes -1/8. And it's negative not because we dealt with a negative power, but because the 2 happened to be negative. That's what made the final answer -1/8. So -1/8 is going to be one of our potential solutions. But remember, we also had this person, this one over here. We're going to do just like we did with the other guy. I'm going to raise both sides to the -3rd power. That's going to leave me with just x on the left-hand side. Now, the cool thing about 1 is that 1 to any power is what? Well, you may or may not have seen this, but 1 is a very special number. 1 to any power is still just 1. Don't believe me? Okay, let's try out through using the little method we just did. That would put that 1 on bottom. That's supposed to be a 3 power. That would cause us to reciprocate. This 1 on top, but then it's going to put the 1 down to the bottom and make it 1 cubed on bottom. And then what is 1 cubed? What is 1 times 1 times 1? Just 1. So then we end up with x equals 1 over 1. But of course, that just simplifies to 1. So our two solutions for this one are going to be -1/8 and +1. Everyone say, whoo! Whoo! Thank you very much. Yeah, that's a lot of heavy lifting. So that's going to be our answer here. Now, you're going to say, Josh, don't we have to check our solutions here? Yes, but we'll save that one for the Saints. We'll let the more noble check the solutions here. It's going to work. We can make an argument for why it's going to work, but let's not rack our brains too horribly much for the moment. So there's two separate solutions here, -1/8 and +1, that could have been plugged in and create a true answer there. Let's talk about this. We used a lot of math today. We used a lot of different math. I did multiplying by hand, negative exponents. We talked about things that are raised to the 4th power. There's a lot of math coming at you real quickly. And that's just kind of the unfortunate truth behind college algebra. Also, another thing to note, and this is just how it is, if you think about it, if you're in a high school class, a class like college algebra in a traditional high school class is really like almost all of Algebra 1 and Algebra 2 mixed together. That's really what college algebra is, and with more of a focus on Algebra 2. And we only have one semester to do it in, whereas if you were taking Algebra 2, you'd usually do it over the fall and spring. On top of that, you guys have roughly 18-week semesters, and in a high school class, I believe you meet a little bit more each week, more physical time than you do in a college class. So if we're talking about time, and let me say this, time is the only resource that exists in the universe, the only true resource, the only natural resource you have. Your time is the most important thing. If you're talking about time, we got to go at an almost breakneck speed. You might have experienced that already in this course. You might say, Josh, you're just going at the speed of light. And yeah, that's just the unfortunate truth. And I hate it. Don't get me wrong, I hate it. If I had my druthers, I would take 2 long semesters to do a college algebra course, and we'd make sure, we were going at a really good clip, but not so horribly fast like I have to go right now. That's just the unfortunate truth. So what I promise to do on the flip side of that is your exams are generally going to be straightforward. When you do your first exam here, don't freak out if you don't quite have the grades you want, because remember, I'm going to collect that work. And my thought is I'm generally going to try and be as generous as possible with points back. If you work a problem and you got it almost completely correct, but you missed a negative sign, and that gives you the wrong answer on the exam, I'm going to go back and I'm going to give you most of the points back on that problem because I can tell you understand what's going on. Literally, MyLabs Plus, that's just where I'm taking in your answers, your physical answers. That's not where I'm grading. That's not the only way I'm grading you on that. So yeah, let's see. On the exam, does it grade your question as we go through the test? No. What you'll do is the exam is designed, it's going to be a 65-minute exam. That's the time you're going to have on it. But that means I've designed it to where 65 minutes should actually be somewhat generous. What you're going to do is you're going to work the exam, work the problems. It'll look kind of like how a homework assignment looks on MyLabs Plus, except it's not going to immediately tell you if you get a problem right or wrong. So it doesn't work like the homework where you get as many tries on a problem. Not at all. It's you just put an answer in and then you got to go on to the next problem. It's going to store your answer. And then when you click submit at the end of the exam, then that's when it's going to tell you if you're right or wrong. Although it should be set to where you can't fully review it, and there's exam security reasons for that, meaning you can't go in and see why you got this one wrong or what the right answers were. You can generally only see your grade, at least initially. So you might see your grade. Again, don't freak out about it. If you were taking good scratch work, if you're taking good notes, and again, please do the problems in order. If you need to skip a problem, you want to come back to it later, leave a nice big blank space for that problem. Because I don't want to grade number 1, then number 7, then number 10, then number 11, and then I'll go back and do number 2 and 3. That's just a horrible jumbled mess. The cleaner you make your scratch work, the easier it is for me to grade. And if it's easier for me to grade, who gets more points back on the exam? I think the answer is YOU. So yeah, it doesn't grade your question as you go through the test. It grades you when you submit the entire thing. So you'll have 65 minutes. The reason I do that is that gives us about 5 minutes to get in there and make sure it's all good. What if we type it in the wrong format and it ends up being wrong, but it's the right answer? Gracie, that is an amazing question. I love your question. And that is literally one of the primary motivating factors why I collect your scratch work. If you have the absolutely correct answer on paper down to a T and you accidentally put it in wrong, or you're right, the formatting, as you've probably noticed, there's some real specific formatting that MyLabs Plus likes. But if you have the right answer in spirit, Gracie, I'm going to give you full credit on that problem because I know you know how to do it, and I'm not going to let typing it in wrong trip us up here. So you will get full credit back on that problem if you are totally right on paper. Then that is literally one of the primary reasons I collect your scratch work, and you are so welcome on that because we kind of have to do everything with an online perspective this semester, just due to all the things going on in the world. But I don't want common sense to be thrown out the window. If you're right and you know what you're doing, but I don't want you to do poorly. That's against the whole point of mathematics. And same if you just make little mistakes, or same here, I want to give you some credit back. So again, don't get depressed. The grade you see in MyLabs is not your final grade on the exam. I'm going to go in, I'm going to look at your work. But you got to get your work into me that day. You can do it when you get home from school or something like that. It should only take 5 minutes to snap some good pictures of your work and then submit it in Canvas there. So that's some good news. 1.7 again is left off the exam. You'll notice whenever you go in to take the exam, you'll all be in the room together on MyLabs Plus on, I assume, your Chromebooks in there. And when you go to click the exam, you will not be able to just open it on your own. It's going to have a password, an exam password that only Mr. Glidewell and I will know. So I will be emailing him the password before the exam. And so that keeps you from trying to do it at home or something like that when you're not in a proctored environment. So you will not know the password, but that's just policy and procedure. So, are there any other questions about the exam format? It's on MyLabs Plus. You can't use a calculator, you can't use notes or anything. But on the flip side, I do give you an exam review. The exam review is on MyLabs Plus. It's in your homework section or under the assignments, but the review itself doesn't count for a grade. It doesn't go into your homework average or anything like that. You don't get bonus points for working the review per se, but it's a great lightning rod. It's where I've gathered the information you need to know. And I think doing the exam is going to help out. In fact, I've had students literally straight up tell me, yeah, you work the review before the exam. It just makes sense. But that's not the only way you can study. You can also work on the homeworks that are open. And remember, on any homework assignment, while it's open, you can work a problem as many times as you want until you get it right. Now, it might only give you 3 tries, and then it's going to try and change the numbers on you. But then you can let it do that change the number thing as many times as it takes till you get it right. But even on homework assignments that are now past due, you can actually, if you click Gradebook and go look at those homework assignments, you can actually reopen the assignment and you can work all the problems in there that you want, and it'll tell you if you're right or wrong. It'll give you new problems with different numbers, and you can do it just for extra practice. It won't improve your grade, but you can do that to get a little bit of extra practice on some of the problems. Even on problems you've already worked and gotten correct, you can still redo them. It'll just regen the problem with new numbers, and it won't affect your grade. It won't lower your grade or anything like that. It's like risk-free. Basically, MyLabs Plus, you can experiment on the homework, and it's risk-free. It will never lower your grade. So there's that. I know the material's tough. I'm hoping you guys will agree that I've given you a fair way to show me that you know what you're doing on the exam. I think everything is kind of fairly set up. You have an opportunity for some bonus points if you do work that 1.7 homework. Any other questions on the exam format? Issues, technical questions? What I'm going to do is I'm still going to log in here in Zoom, but it's just to make sure that everything's smoothed over technically. You guys have started properly, and then I will likely maybe log out of Zoom, maybe not. Okay, we have a few minutes left. Do you guys have any specific concepts you'd like me to review? It was good. We got that nice factoring problem in. You can use that factor by grouping method, and it's the bee's knees. I can work another factor by grouping problem if you want. Or if you guys just have any other questions over specific content that you'd like me to review. Lily would like to know if there's any word problems. If so, how many? Well, yes, because section 1.5 was that quadratic applications section. And the word application in math, you might as well just say that means word problems. So yes, there will be a handful of word problems, but it's not an overbearing part of the exam. In fact, I've kind of cherry-picked them to be straightforward, not really any curveballs in there. So I know everyone's like, oh gosh, word problems, I hate them. Yes, they are not fun, but that is kind of where the math comes together. And the problem is when you're teaching word problems, all I can do is teach you kind of the intuition behind it and go over it slowly, but there's still some things you got to bring in and work hard or come in with yourself. So yes, there will be some word problems. The nice thing is, though, again, if you're taking good notes, you can potentially, if you completely just bomb a word problem, but I can see that the gears were starting to turn and that you're starting to set up the equation properly, then you can still get some partial credit on those when I see your work. So yes, there will be some word problems. A few tips for word problems. If you go look up, there's a famous problem solver of the 20th century named Polya, P-O-L-Y-A. I'll just write it here on the whiteboard. Polya. And if you look at Polya's 4-step problem solving technique, solving. This is a math class, not an English class. I don't promise to know how to spell things, all right? If you look up Polya's 4-step problem solving method, technique, it actually, believe it or not, it's going to be corny, and you're like, oh, I don't want to. Trust me, it's a lot more helpful than you think, because Polya really asks you think about the problem before you start doing it, and then start taking notes on the problem. You got a word problem? Take a few notes. The basic process behind a word problem is that you need to introduce a variable, and for our word problems, variables are generally going to be representing something we don't know that we're trying to figure out, which is why we usually have to solve an equation, because solving the equation gives us the value of the variable. So you generally are going to want to make the variable whatever piece of the problem you're looking for, whatever it is you don't know that you're trying to find. And it doesn't hurt for you to literally when you're working on your scratch work, say, okay, I'm looking for consecutive odd integers that multiply to 63. Okay, I'm going to let x be the first odd integer, the thing I don't know. And then you can introduce a second variable. You can say y will be the second odd integer. So here, I'll just write it out, just deconstruction here. So find two consecutive odd integers that multiply to 63. That's the one we worked the other day in class in this section. Okay, two consecutive odd integers, those are the things we're trying to find. So I'm not even going to think twice about it. I know I need to find two odd integers, so I'm going to let x be the first odd integer. And then I'm just going to let y be the second odd integer. That's a great first step. That I almost hate to call it this. It's kind of gross sounding, but I'm just going to say it. Sometimes you just need to barf out your thoughts when you're working on a word problem. Just barf them out, get them out there. Now, let's use a little logic here. We have two variables, x and y. But wait a minute, two variable equations can get nasty quickly, and we are not at the level where we really deal with two variable equations, not in spirit. We might say y equals x squared minus 2x plus 1, but we're actually, the y is just not really a variable we're trying to solve for per se. So in reality, we can't quite deal with two variable equations. So what we need to do is we need to appeal to the information the problem has given us. Two consecutive odd integers. If they're consecutive odd integers, that would be like 9 and 11, or 11 and 13, or 13 and 15. They're 2 units apart from each other. So if I'm letting x be the first odd integer, initially I can say y will be the second one, but now I need to use the actual relationship that exists between them, and I need to say that x plus 2 is going to be the second odd integer. And now check it out. I've got both the things I'm trying to figure out, but I only have one variable that I need to solve for between them. And then the equation you set up is how I'm going to utilize the last bit of information. So two consecutive odd integers multiply to 63. So the first one, we called it x. I got to multiply it to the second one, and I got to put it in parentheses. And that's supposed to come out to 63. So it always helps on those problems to first declare a variable. Usually you'll use x, figure out all the things you're trying to solve for, and then write them in terms of a variable and then a relationship to that initial variable, and then set up an equation that utilizes the rest of the information, solve that thing. Polya's 4-step problem solving technique or method is going to be an excellent thing for you to do there. Any other quick questions on that? Quick questions on the exam? All right, it sounds like time. Y'all have a great day. We'll see you Thursday in Zoom for exam 1.
Sure. Alex, I need you in the counselor's office.